Hey guys, I hope you're doing great today. Well, our journey with Terraform learning is going great so far. And today we are going to discuss and we are going to learn about Terraform modules. You guys know that I have created this repository, Terraform by DevOps Molvi, and in which we have been sharing together everything that we have worked so far. So we have covered Lab 2, we have also covered infrastructure provisioning on Azure and GCP. Today we are going to talk and learn how modules work in Terraform. So I have created this separate new directory, Terraform Modules by DevOps Molvi, and since I'm sharing this repository URL in the description of every video so far, so make sure to check out the description and you will find this repository link. It is a public repository. So let's get started with Terraform modules. And I have this Terraform modules directory, but first we must know what is a Terraform module. Guys, the simplest definition of Terraform module is that a set of configuration files in a single directory is a module. Okay, I have a directory and I have only one main.tf file, then it is a module. Now further, if we explain it further, and we will definitely see how modules work in Terraform, you can see that I have this directory infrastructure, and now this directory contains 4 more directories, and the purpose of Terraform modules is to reuse for our infrastructure provisioning. I will use that code again and again. I will reuse actually, so that I can provision infrastructure, and that's the purpose of Terraform modules. When you have to reuse the code, this is actually Terraform moduling. This process is actually known as Terraform modules, or we can create Terraform modules ourselves, and we can also use the Terraform modules that are provided officially from the Terraform registry. So for learning our own learning and knowing Terraform modules more better, I have created this lab, and in which we have these 4 directories. Now guys, for your understanding, these are 4 Terraform modules, okay, and these are actually child modules. Why these are child modules? Because I will run Terraform commands from this directory, which is my parent directory, Terraform modules by DevOps Molvi. I can show you from here, ls-l, and I have this Terraform modules by DevOps Molvi, and you can see I have a main.tf file here as well, and I have infrastructure directory. Now this would be considered as the root module, because I will run Terraform commands in front of you from this directory, okay, and I have this main.tf file, and this main.tf file actually has every information for the child module, okay, and I will run, you can see I have terraform.tf state file and terraform.tf state.backup files in this directory, which is Terraform modules by DevOps Molvi directory. So we can say that this is actually a a root module. And in infra, we have these 4 directories. These are actually considered as our child modules. And when I run Terraform command, what will happen? We are going to create 3 VMs, okay, for our development environment, and we are going to create a storage account and a blob container. So that is the purpose of modules. Instead of having one main.tf, one variables.tf file, and one outputs.tf file, provider.tf file in one directory, it can become so complex, and it would be really hard for a DevOps engineer to organize that infrastructure. So that is actually the purpose of creating separate Terraform modules. Now each directory should contain a main.tf file. Okay, and these directories are, I'm repeating again and again, these directories are actually considered as child module. And why these are child module? Because I will not run Terraform commands from these directories. Each directory has Terraform configuration files, but I will run my Terraform commands from here, which should be considered as our root module. Okay, now you must understand the difference between a root module and a child module. The folder or a directory from where you're running Terraform commands is considered as the root module, and the other folders which have the configuration files to provision infrastructure are known as child module. Okay, now I hope that you understand the difference between a root module and a child module. Now this directory infra contains 4 more directories. Okay, and now each directory has a main.tf file, you can see, an outputs.tf file, and a variables.tf file. So each of these modules is actually managed by the main.tf file, which is the root module. So first of all, we have to go through this main.tf file. And now you will see, let me open another tab so that I will have a duplicate, and this is our infrastructure folder, and for instance I'm starting with VM1. Okay, and VM1 has these configuration files to provision a virtual machine on Azure. So now you can see the same practice that we have done so far. Okay, while provisioning infrastructure, provisioning VMs and storage accounts. If you have watched my earlier labs, you must know about provider and these subscription IDs, client ID. We have to create a principal, and we have to paste our subscription ID, client secret, and tenant IDs here, so that our Terraform can talk to our cloud, Azure cloud, to provision infrastructure. Now guys, this is actually my first module, and this is VM1. If you understand this one, then the rest of the configuration and the rest of the modules are totally same. Okay, so you have to understand this one. So now you can see we have the module information here. Okay, now it will create a virtual machine, and the virtual machine name would be DevOps Molvi 1 VM. Similarly, the other VMs have DevOps Molvi 2, and this one has the DevOps Molvi 3 VM. All right, this one. So first of all, you can see I have given every required information about my virtual machine 1, and this module will use this directory VM1, which is a child module, to provision virtual machine on Azure. Now you can see we have source. Where is the source? We have the source from here in infra VM1. Now you can see I have this source, and this is actually the syntax to give the source information from where our root module will get all the values to provision a virtual machine, and this would be our source, and every information in that source should be given so that we get no issues while provisioning our virtual machine. And now you can see we have the source VM1, which contains our variables.tf, outputs.tf, and main.tf file. Now I have resource group name, location, virtual net, subnet name, virtual machine size, and this would be the username and password for SSH access. Okay, for SSH, and this is the image publisher, and we will have three virtual machines with 18.04 long-term support Ubuntu release installed on each. And the tag of each virtual machine would be environment, because these are created for dev environment. So each virtual machine will have this tag. Okay, now you can see the other virtual machines have the same specs and everything is almost the same. Instead, the source of the rest of the virtual machine would be different, because now you can see the virtual machine 2, which is our second module, and it has this source VM2, and we have this VM2 as well. You can see VM2, similarly we have VM3, and similarly we have for storage for our storage account. And now you can see rest of the values are same, because I'm creating my infrastructure in a single region, which is East Asia, under one resource group. So I don't want to create a huge mess creating separate resource groups, separate regions, etc. So I want that my virtual machines and my storage are in the same resource group and in the same region. So it will, I mean, it is easy to organize. It is better to understand what we have in which region and in which resource group. So we have this one virtual network, we have the same subnet, and similarly the virtual machine names would be different, right? So from that perspective, I have three virtual machine names: DevOps Molvi 1, 2, 3 virtual machines. And I can have the same password for our virtual machines. All three virtual machines can have one password, similar password. Now it is up to you. So this would be my admin username, which will be a sudo user, and I will have the password, and release and version of the operating system would be the same. Similarly, we have this module, our third module, VM3, and I have the source here, VM3, and you can see we have the same resource group, East Asia, and the rest of the information is almost the same. This is just the duplicate copies. Okay, now I hope that you can understand it better. If you can create one virtual machine, it would be easy to reuse that code for creating other machines. Now I can use the same code to provision 10 or 20 or 30 machines, right? This would be the major advantage of Terraform modules. We are reusing code. That code is being reused to provision our infrastructure, which is the core concept of Terraform modules. To reuse code. Okay, I hope that now you understand it better, because we have one virtual machine and that same code is reused for provisioning other two virtual machine, except for changing the major information like the source of the child module and the name of the virtual machine name. So it will create an error that the virtual machine with that name already exists. So that is why I'm creating three virtual machine with three different names, right? And this username and password, I have kept it the same username and same password, so you can have different as per your choice, and the release and operating system version is the same. Now guys, the last module is our storage module, and you can see we have this source of that module and I have this storage here, and it will create a, you can see it will create a storage account and a blob container, just like we did in our previous lecture as well. We are going to create a storage account in East Asia, and the storage account name would be DevOps Molvi storage, and the blob container which will contain our files and our data is, and it will be DevOps Molvi. So this would be our container name. Okay, so I have these four. So guys, Terraform by DevOps Molvi, you can go here and you can find Terraform modules by DevOps Molvi and this main.tf file. Okay, so I would recommend that when you clone this repository, you must change the values so that you can better understand how the infrastructure is being provisioned. All right, so this was actually our root module, and this directory infra contains the information about our child modules. Okay, so first of all, if I go to the storage module, it contains a main.tf file, and we have the information about our resource group. Okay, this is our resource, and var.resource group name. Okay, and I have this variables.tf as well, from where we are getting our variables. So similarly, we have the storage account. That is actually the same practice, and I hope that you know about these code blocks. What are we doing in each code block? So I will not going to repeat it, since we have already done it multiple times, but just sharing the overview that what's going on in each module. And you can see we have this container. Now I have this var.container name, so we must have a variables.tf file, you can see here, and every variable is given here: container name, storage account name, location, resource group name, and each variable will have the values taken from here. Okay, you can see we have var.resource group name, so it would be DevOps Molvi resource group. We have var.location, the location will be East Asia. Similarly, we have var.storage account name. All right, so we are having the values here, and all these values are being used by these child modules in storage. And similarly, if we go to infrastructure, we have the VM1, and if you understand how VM1 is being provisioned, you will be able to understand the rest of the virtual machines. So it also has a main.tf file which contains the resources that we are going to provision. Okay, for each virtual machine we will have these resources. The resource group will be same for all these three machines and the storage account. So we will be having only one resource group. We can see the resource group here as well. So after provisioning the infrastructure, we are going to see the resource group here. So we will definitely check it in a couple of moments, and we will have a virtual network for 3 virtual machines. We will have the subnet, and guys, make sure that we can have the different address prefixes to avoid any conflict. Okay, I will have the different address prefixes and the network interface card for public IP addresses, and this is actually the resource block for provisioning our virtual machine. And every information we have, like if I talk about var.vm underscore size, so we must have this. You can see VM size should be standard v1s, so it is the same size for all the rest of the VMs. And we have the OS disk, and it is actually standard locally redundant storage for all the rest of the virtual machines. And similarly, we have tags, var.tags, and each virtual machine will have the tag as the dev virtual machine. This would be the tag, and each virtual machine is a dev machine. So guys, this is the main.tf for our virtual machine 1. Similarly, we have the main.tf file for virtual machine 2 and virtual machine 3. Okay, if you want to see, I can go to infra, and we can have a look on VM2. You can see we have configuration files for VM2. Now these are modules. Okay, these are Terraform modules because we are having Terraform configuration files in a separate dedicated directory. This is what a Terraform module is. And similarly, we have the outputs.tf, and we have the variables.tf file for all the rest of the virtual machines. And what is the purpose of outputs.tf? The purpose of outputs.tf file is to share the data among different modules. So that is why you will see the outputs.tf file in each module. You can say that outputs.tf file is used for sharing the data between the root module and the child modules. So that is the purpose of outputs.tf. And similarly, if we want to declare the variables, we have this variables.tf file, and it contains the information like resource group variable and their type, location variable and its type, and vnet variables, and all these variables are used in our main.tf file in each module. So you can see we are using these variables in our main.tf file. So guys, that was actually an overview how modules work, and you can see I have this dedicated directory created with a root module, and we can see we have 3 virtual machines and a storage that we are going to configure, that we are going to provision using Terraform. So you can take the clone of this repository, and then you can try at your virtual machine and make sure that you have created a principal, and you need subscription IDs, and these rest of the all IDs should be there in your main.tf file. So you need a principal first created, and make sure that you must give the subscription IDs and the rest of the client ID and tenant ID and client secrets here, so that you do not face any issue while running Terraform commands. Alright guys, now let's see what we have here. I have the same configuration, same folders, same directory structure, same modules, and a root module here. So I will be running my Terraform commands from here. This is our main.tf, and similarly we have this infra directory, and it contains our child modules. So let's run and see what we get. Okay, so I will clear it, and let's change the settings. This font is a little bigger and I have to change it. Okay, so I hope that you might able to see it as well. Now I will run Terraform init command. Okay, initializing the backend and initializing modules. Okay, you can see our modules have been initialized. Now I will run Terraform plan, and it will share a huge output. That is actually a huge output, because we are going to create almost 15 plus resources, and let's see how many in total we are going to provision while running Terraform plan. All right. Okay, now you can see the plan is to add 18 resources, and we are going to change 0 and 0 to destroy. So everything is going to be a provision from scratch. So in total we are going to add 18 resources, and if I have a quick look on our Terraform plan, then you can see it is saying that refreshing state. Guys, I am having my terraform.tf state locally on my virtual machine, since it is just a dev environment. And note, objects have changed outside of Terraform. Terraform detected the following changes made outside of Terraform. Okay, so since I have been working on this directory, I have been provisioning virtual machines and storage account. So you may not get this message or note, but since I have been working for the last couple of hours, so that is why these are, guys, the modules. Okay, and now Terraform will use the selected providers to generate the following execution plan. Now this is actually our module information. This would be our storage module, and this would be our account storage, the information about our account storage, and similarly our virtual machine 1, our second module, the information about our virtual machine resource group, subnet, and this is actually the virtual machine. Now you can see we have this name virtual machine 1 for our VM1, and similarly we have the rest of the modules for our virtual machine 2. Okay, this is our second module, and similarly we will have the name here. Guys, this is just a plain JSON file, so I hope that you don't have any issues while reading this JSON. And similarly you can now see we have this DevOps Molvi 2. This would be our third virtual machine, and it is our third module. And every information we have here: resource group, subnet, and virtual machine, vnet, virtual network, and os profile, storage, data disk, release, everything in Terraform plan. So now we are going to run Terraform apply, and that Terraform apply is going to take some time because we are going to provision 18 resources. So I will run Terraform apply and auto approve. Okay, auto approve, and I don't have to give yes when it asks, and it is actually auto approved. So now take some rest, and we will see how much time will it take to provision our virtual machine. So it has been started. Okay, and now you can see the virtual machine resource group is going to be created, and similarly our modules are in the process of creation. So I will sit back and see. So by the way, Terraform apply is you can say that it is the real-time logs of your infrastructure. You can see the real-time logs, what your infrastructure, how it is being provisioned. So these are actually, I would say that these are logs or the information about how our infrastructure is being created. You can see still creating, and some are creation complete after 18 seconds. So that's how Terraform apply shows us the real-time information. Alright guys, Terraform apply has been completed, and you can see we have our DevOps resource group. So we have every information. Now you can see we have the DevOps Molvi storage account. For instance, if I open it in a separate VM, we have the virtual machine 2, virtual machine 3. And for instance, if I click on this virtual machine just to see how and you can see it is already in running state, we have the size here, and in a moment I hope that we get the rest of the information. I will just refresh it, and we will get the public IP address and the time created here. So this is our storage, DevOps Molvi storage account, and I will just refresh it again. So you can see we have this storage. Okay, as per our infrastructure we have this storage infra, and we have a storage module, and here we can see the resource group and our storage. It is all LRS, locally redundant storage, and we have a blob container as well. So if I click on blob container, it should have one container created. And similarly, if I go to my DevOps Molvi resource group, the rest of the provisioned resources, we can see all of them in this one resource group. Okay, so you can see every resource has one region, and each DevOps Molvi 2 VM, 3 VM, similarly we have 1 VM, and this is, you can see the storage, and we have this blob container which should be empty because we don't have any data. But you can see our modules have been provisioned. We have our infrastructure, and we use Terraform modules to build all of these. And we have disk network interface cards in each in one location, okay? And we have virtual machine NIC network interface cards as well. So for instance, if I go to DevOps Molvi 3, so these are actually the separate 3 virtual machines, right? And every virtual machine is running in East Asia region. So guys, that's how we can use Terraform modules. So I will definitely share the repository URL. So you must clone it and you must run it on your virtual machine, and you will see the magic. You will see your virtual machine storage account and every. You can add more virtual machines. You can add more storage accounts in this configuration. You must modify it. This was just an overview how Terraform modules work, and I hope that you have enjoyed this virtual lab with me. So I will definitely share more about Terraform in the upcoming lecture. We are going to discuss about Terraform interview questions and answers. So make sure that you subscribe DevOps Molvi. I will watch you in the next video. Have a good one. Bye.